Hey guys, today we are going to start with our one variable statistics unit. And the first thing we're going to talk about is how to represent this data specifically with graphing. Okay? So, the first type of graphing for one variable statistics is the histogram. Now, the histogram is very similar in a lot of ways to a bar graph, but it is quite different when you sort of look more intense. So the number one thing about a histogram is that this is often used. Whoa, that's really thick. Let's oh, okay, there we go. So there we go. All right, this is used for continuous data. Okay, continuous data. Now, that's not to say this won't work with discrete data, but it is one of very few methods of graphing that will work with continuous data, so it's often what we will use. So when you're dealing with continuous data, if you need to represent it, the histogram is almost always the way to go. All right, so the primary difference between a histogram and a bar graph is that each bar is going to represent an interval, all right, rather than just a specific outcome. Also, it's important to realize that the intervals or the bars must touch each other because there's nothing in between the bars. There's no space because we are using these intervals, okay? So first of all, we're going to go through this problem one at a time and you'll see how we create it. So a report of mathematics marks, I'm not sure why I called it mathematics, prepared for the principal. One teacher records all this stuff. All right. So the first thing we need to do is we need to figure out how big to make each interval. So typically you want to have between 5 and 20 intervals. All right. So for this one, you can see we've done it here, and we could, if we wanted 5 intervals or bars, we could have 10 each. Interval is 10 units wide, or we could use as small as 2.35. All right. So the thing here is, what's important is it's very difficult sometimes. If you make the bars too wide, it won't tell you anything because won't be enough bars to show a pattern. But if you make them too small, it'll be just as meaningless. So the sweet spot's somewhere in between 5 and 20 intervals. All right. So we're going to use 10 here, which is maybe a little on the big side, but it's good enough. You wouldn't want to go any bigger than 10. 5 would probably be the most meaningful for this one, to be honest, but because of what it's about, because it's about marks, we're going to use 10s, just because that kind of makes more sense in the context of the problem. So when we're labeling our intervals, you'll notice we're going to call it 60 to 70, that's how we write it. So this goes anywhere between 60 and 70. You'll notice we have this round bracket here. That shows that if we got the mark 60 dead on, it would not be included in this interval, okay? If we use the square bracket, so if we got a 70 dead on, it is included, all right? So the 60 is not included, the 70 is. That way you're not counting those marks more than once, all right? So in this case, a good start interval is going to be 40 to 50 because that's going to sort of include our first mark. So what you're going to do is you're just going to set up these intervals. You're just going to go through and you say, okay, so we went 40 to 50. Now we're going to go 50 to 60. And again, we'll do a square bracket there, a round bracket here. Okay, and then we'll go 60 to 70. And we just go all the way through up to 100. Square brackets showing that it's included. And we'll go 70, 80, 90, round, round, round. All right. And then what we'll do is we're just going to tally up how much of each there are. So we just go through, and the first mark was 52, so we put a tick in the one that includes 52. Then we had a 66, which is in there, a 75, which is there, an 80, which is, oh, I almost did it wrong. I almost put it there, and that would have been wrong, of course, because 80 is included in this interval. All right, so then we'll have a 52, and so on and so forth. And through the magic of the interval, I finished all of those. So now we just go through and we just add them all up. So we say, well, there's 1 in that interval. There were 3 in that interval. And of course, you'll notice I started with the lowest interval that we had data in. There's no point in drawing or writing the, like if you look and there's nothing in the 30s, don't bother including the 30s. All right. We'll take that into account when we draw the graph, but at this point, there's no point. So then anyway, we got 7, we got 7, we got 5, and we got 1. And hopefully I didn't make any mistakes there. So now it's a good idea to go through and just total them up. So we say, well, at this point there was 1, and we say, then there were 3 more, which makes 4. Then there's 7 more, which makes 11. 7 more, which makes 18. 5 more makes 23, and 1 more makes 24. And there we go. All right, so we've got it all in a table, and we're good to go. All right, so the idea of that frequency, that thing that I just did there, is just you knew that there were 24 people, or hopefully you knew there were 24 people, and so you know that you didn't miss anyone, because the biggest problem you'll run into with these things is when you do that tally chart, you'll just miss one of the numbers. All right, so now what we're going to do is we're going to put it into this table. So it is important to realize that the y-axis is always the frequency, and the x-axis always represents the intervals. Okay, now what I was talking about earlier is right here. We are not starting at 0. Our first interval started at 40. So we are going to include a break in our graph, and that's very important. You don't have to do like the squiggly thing like you learned in grade 9 or grade 8 or whenever it was. You just leave a gap, and you just show that. So we're not going to start right here. That's not going to be 40 because that's not the beginning. All right. So we'll just leave this sort of square right there, blank. Maybe even another one. We'll see. So anyway, the other thing is, like I said before, there are no spaces between the bars since the intervals are continuous. So the bar goes right up to 60, and so then the next one will pick up at 70, or pick up at 60, sorry. Okay. All right, so I'm going to draw the first bit here, but I'm going to start by labeling the side as frequency. I'm going to zoom in because that's real messy. Whoops. Oh, that was no... I'm not sure that was any neater. All right. So we're going to do the frequency, and we're just going to look here, and we'll go 1, 2, 3, 4, 5, 6, 7, 8. And I could keep going, but of course the highest frequency we have is 7, so I'll just leave that there. All right, and so now I'm going to label the intervals. Now I do have to give this a title, so this is going to be marks, and that is a percentage. So, but we're just going to go and we say, so I'll pick up right here. Okay, so I'm just going to start at, right, let's see. So we'll go from here to here, and we're going to call that 40 to 50. Okay, so then we just go and we look. Well, there was only one, I'm not sure why I'm using red here, but there was only one person in that bar, and so we just do that. All right. And of course there's no rules about using color or anything, but I've got this fancy thing here, so I'm just going to do that. My next one I will call 50 to 60, and I look, and in my tally chart I had 3, so I will go up 2, 3. Oh, let's try this. There we go. Let's go to there, like that, and there we go. Again, notice these bars are touching. That is important. All right, the bars have to be touching to show that the number 50 is right in the green, or sorry, it's right in the red. If I went 50.0001, it would be into the green. All right, so that is very important. I realize these marks didn't have infinite decimals, but it doesn't matter. Okay, you have to do that when you're doing these. All right, and so then we're just going to continue on. And there we go. All right. So you can see the idea of these histograms is that it's showing the trend of the data. You can see, and this is where the bell curve we often will talk about comes from, is you're sort of, you know, you're showing the basic shape of these marks here. Okay. All right, that's sort of the most complicated one we're going to look at. So let's look at some more straightforward ones, most of which you've probably seen. So bar graph, I would hope you've seen a bar graph. So I've got some data here that just shows how much or how many goals each of these hockey players scored. How many goals? My grammar is real good today. Anyway, so we're just going to graph this normally. Okay, but before we do, I want to talk about when to use it. So first of all, a bar graph, again, you should have, the frequency should always be the y-axis. It won't always be. Yeah, the y-axis should be the frequency. Excel will often give you going side to side because they think it looks neat. It's not technically correct, but it's not that big of a deal because it's a bar graph and people don't typically care. If you are using numbers, like if down here, if your x-axis is numbers, it won't be for us because we're doing hockey players. You would do that gap at the beginning, just like we did. If I go back to our, if I go back to our histogram, we included this gap here, okay? You would include that as well if you don't start at 0 and it is numbers. But often you're not. Usually these are categories. Often you're just doing a tally. Bar graphs are most often used for categoric data or qualitative data rather than quantitative. All right. And so these are pretty straightforward. You're just going to list your hockey players, your players' names here. Okay, I'm not even going to actually do this one because I think you know how to do a bar graph. Okay, and you just write the frequency. In this case, it's the goals, or so goals. All right, and you would just write the numbers, and you draw your bars. Okay, so. Am I doing a terrible job here? Yes, I am, but that's okay because the most important thing I want to show you is that I have gaps in between my bars. And that may seem unnecessary, but it is technically necessary for a bar graph. You should have gaps in between your bars for a bar graph. Okay, that's one of the primary differences between a bar graph and a histogram. All right. I mean, that's basically it. All right, you should know how to do a bar graph at this point. If you need any more clarification than that, please ask me in class. All right, let's move on to a circle graph, which is also called a pie chart, of course. All right, this one, even though this one seems a little more simple than the bar graph, it's actually often the one that people have more difficulty with. But of course, it's fairly straightforward. What you're going to do is you're just going to figure out the percentage of the circle that is going to be in a certain category. So here we've got 5 categories here. Okay, so we're going to have 5 sections of the circle graph. And you're just going to figure out the percentage. So the first thing that you need to do is you need to find, well, let me switch to a reasonable thickness there. You have to find let's try that at one last time. Total. You got to find the total. You got to add these numbers all up. So in this case, if we add these all up, it's going to give me $2,100. All right. So what you're going to do is you're going to take each of them and you're going to do whatever the cost was. You're going to find the percentage by dividing by the total. And then you're just going to multiply that by 360 degrees. All right, 360 degrees. And we just do an approximation here, which is about 154.3 degrees, we'll say. Okay, and there we go. So now you know when you're measuring it, that is the angle that you need to do. So you'll just use your protractor. That's the angle that you should create. You'll know you did it right because you'll get to the last pi section, and when we get to entertainment, you'll measure how many degrees it is, and if we did it right, it should be about the same number that your math told you it should be. All right, so I'm just going to do these ones really quick. And there we go. So there's the total number of degrees, and if you add all of these up, it does indeed equal 360 degrees. You might be off by 0.1 or so, but that doesn't really matter. It's close enough because you're just drawing it on a graph. All right, and so from there, you'll just draw your vertical line, and then you just measure out 154 degrees, which it's going to be like, I don't know, something like that. It doesn't matter. You can do it yourself if you want. And then you just finish the others. So let's do 60. It'll be something like that. That'll be something like that. That'll be there. It doesn't matter. Whatever. You measure the last section right there. Measure that angle and make sure that it equals more or less that one right there. All right? That is that. Yeah. Stem and leaf plots. So stem and leaf plots, I'll tell you right now, stem and leaf plots is the one that I always ask on a test. I always ask on a test. I always ask on a test. And everybody always gets it wrong. All right? It's actually very straightforward, but you do need to remember how to do it. So what you're going to do is you're going to start by rewriting these in order. You don't even actually have to do that. So I'm not even going to do that. What I'm going to do instead is I'm going to do an out of order stem and leaf plot. All right, so I'm not strictly doing what it tells me to do here. I'm going to write the stem right there and the leaf right there. It's a fancy name for something that's really pretty straightforward. But what I'm going to do is I'm going to do an out of order one, and then I'm going to transfer it into an in order one. So what you're going to do is your stem is the tens digit. All right, so our first stem would be 0. All right, and I don't actually think there are any zeros in this one, so I'm not even going to do that one. Yeah, that would just be, you'd write the 0 for if there were anything that wasn't even bigger than 10. There isn't, so I can even ignore that one. And so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. I ran out of room. 9. I'll pick up over here. 10, 11, 12. All right, so you can go past, even though it's the tens digit, you can actually go past the nines, just because if you have 100, it's going to have basically a tens digit of 10. All right, and so what you do is you're going to go through. So let's just mark here. So we'll do. We've got 112. So 112 is going to have a leaf of 2. So if you combine the 11 and the 2, it makes 112. All right, so then I move on to 98, and I will just write, I won't write it with that size of a thing, I'll just write 8. All right, then we got 108, so I put an 8 in 10. All right, and I just continue all the way through. Okay, so I just went ahead a bit there, and I got to where I had 106, which I already had 108, so I just put a comma and I put a 6. Now you're going to want these in numeric order, but the first time through, you don't worry about that. We'll then do sort of a good copy, and we'll put them all in order. And there we go. So I've got them all done. All right. You'll notice that 6 is just blank because there were no 60s, or if there were, I missed them. I don't see any. Okay. So what we're going to do now is we're just going to redo it in this sort of nicer one here. And what you're going to do is you're just going to take all the different ones and put them in order. So if I zoom in, and I just write all my stems in like that. Now I'm just going to go up, and I'm going to look, and for the stem of 1, the only leaf it had was 6. So I just write a 6. All right. For the stem of 2, we had 4, 5, and 1. So you're just going to write them in order. You're just going to write 1, 4, 5. All right. For 3, we had 0, 4, 3, 3. 0. And here where you have 2 3s, you just write it twice. 3, 3, 4. And that's it. You just continue. And there we go. There's our stem and leaf plot. It's just an interesting way to sort of organize our numbers there. All right. All right. So that is it. There are other types of graphs that we could do. We're going to talk about box and whiskers plots in particular a little later on. But those are your primary ones there. Yeah, so the only other one that I really want to go in depth with is the box and whisker plot, but we will learn about that more later on in the unit. Okay, so that's it. Until next time, go Sabres.